This is chapter P.5, Algebraic Expressions, Day 1. First, we're going to start with talking about the different types of polynomials. You have this chart here, this table, with all sorts of types of polynomials. We have to determine the number of terms, the type of polynomial, what are the terms, and the degree of the polynomial. The terms of a polynomial are separated by plus and minus signs, and therefore you can determine the number of terms. For example, here this is 1, 2, and 3 terms. The type of polynomial is based on the number of terms. Whenever you have 3 terms, your polynomial is a trinomial. A tri for 3 for trinomial. The specific terms are 2x squared, and then because this is minus, this is going to be this term is a negative 3x, so negative 3x, and then this is a plus sign, so that one just stays 4. So those are the terms. And when you talk about the degree of a polynomial, the degree is the largest exponent that you see on the variable that is given. So right now we have a 2 on this one. That's our largest exponent. Therefore, the degree of that polynomial is 2. Looking at the second polynomial, we have 2 terms there, 1 plus sign, so 2 terms. 2 terms is a binomial, like a bicycle, has two wheels, so a binomial. The terms themselves are x to the 8th and 5x, and the degree is 8. This next polynomial, there are 1, 2, 3, and 4. That 1/2 is being multiplied by the x to the 3rd, so that goes along with that term. So we have 4 terms. That is just a 4-term 4-term polynomial. There's not a specific special name like these two. So this is just a 4-term polynomial. The actual terms themselves are 3. Again, because this is a minus x, we are going to put negative x. We have x squared, and we have a negative 1/2 x to the 3rd. The largest exponent that I have is a 3, therefore the degree is 3. The next polynomial, we have 2 terms. Again, this is a binomial. The terms themselves are 5x and 1. With this, you need to understand that the exponent on x is 1, so therefore the degree is 1. This next polynomial only has 1 term. When you only have 1 term, that is called a monomial. The term is 9x to the 5th, and the degree is the exponent of 5, so 5. The value of 6 is still considered a polynomial. It has 1 term. It, again, is a monomial. The term is 6. The degree, there is no variable here. If you were to put a variable, it would have to have an exponent of 0, because x to the 0 is 1, and 1 times 6 is 6. And so therefore the degree is 0. And down at the bottom I have a description here to tell you what polynomials are. And I just say that terms are added or subtracted together. Down here, yeah, I would just say for the number of terms, you count them. The type of a polynomial is based on the number of terms. The actual terms themselves, you look at them as though they are being separated. That would be an A. By plus signs. And that's where, if you think about that being a plus sign, if you see a minus sign, that's adding the negative. So, 3 minus x would be the same thing as 3 plus a negative x. So therefore, when you separate it by a plus sign, you can see that is a negative x. And lastly, the degree is the highest or largest. I'm going to change that. So the largest exponent that is on a variable. Okay? Now, sometimes there are expressions that can be determined as a polynomial, but sometimes there are expressions that are not a polynomial. So a polynomial is made up of terms that are added or subtracted together, just like we saw above, and the exponents are positive integers. So that's what determines a polynomial. So sometimes we work with expressions that we look at similar to polynomials, but they really are not polynomials. So here's how we can look at these to determine if they're a polynomial or not, is by having exponents that are positive integers. So a polynomial would look like this: 3 times x to the 5 plus the square root of 2 times x to the third. Notice the radical does not go over x to the third, and then plus 1/4. So that works. An example of a non-polynomial would be if you had the radical go over the x, so like the square root of 2x. Or if this went over all the way over x cubed, that would not be a polynomial anymore. Another polynomial would be 1 over the square root of 5 times x. Again, the x is separate, and the x is not in the denominator, because that would give it a exponent of -1. So 1 over the square root of 5 times x minus 8, that is a polynomial. And you got to move that 1 over. This would not be a polynomial because x is in a denominator, and this is the same thing as saying 3x minus 5 to the -1, which gives that variable a -1 exponent. I would not actually distribute that -1 because this is not multiplication or division. You can only distribute exponents when you have multiplication or division. So we'll be actually talking about that later on in this video, but I thought I would mention it here as well. So polynomials and not polynomials. Let's look at adding and subtracting polynomials. Here's an example of adding. When you add or subtract polynomials, you are combining like terms. I will use CLT as a acronym to just make it a little easier when I'm writing. an explanation. So if I combine like terms, I'm going to line these up, and I can line them vertically and add them going down. So x to the third minus 6x squared plus 2x plus 4, and I'm going to make these columns here and add these together. So then I have my other polynomial, which is x to the third positive 5x squared negative 7x, and I don't have a constant over here like the 4, so I'm going to just put plus 0. When I add x to the third plus x to the third, I do not change the exponent. I'm only adding the coefficient. So 2x to the third. Negative 6x squared plus 5x squared is going to be negative 1x squared. 2x minus 7x is negative 5x. And then 4 plus 0 is 4, and I'm going to put plus there. So right here, you can see my answer of 2x to the third minus x 1x squared. You don't need the 1 there. Minus 5x plus 4. Okay? Now, when I'm subtracting polynomials, you need to consider that the subtraction is affecting every single term in that second parentheses. And 5x squared is only one term. I messed up on that for first that rainbow the first time I was doing it. So that's going to be minus x cubed. Minus a positive is minus 5x squared. Minus a negative 7x is going to be plus 7x. And so I've got x cubed minus 6x squared plus 2x plus 4, and then the rest here. Minus x cubed minus 5x squared plus 7x. Now I'm going to combine like terms just like I did above. So I'm going to put x cubed minus 6x squared plus 2x plus 4 minus x cubed minus 5x squared plus 7x. And again, I have no 0 here, so plus 0. So that's, again, I'm going to put these down, and I'm going to add these now. X cubed plus a negative x cubed is going to be 0. Negative 6x squared plus a negative 5x squared is negative 11x squared. 2x plus 7x is positive 9x. And 4 plus 0 is positive 4. And so here's my answer. Negative 11x squared plus 9x plus 4. So the biggest difference here is with that subtraction, you need to distribute that into the second set of parentheses. Okay, now we've got this example where we're going to start multiplying into the polynomials. So with this 7 out front, I need to apply the distribution property. And I get 7 times 2x, which is 14x. And then I'm going to get 7 times 3, which is positive 21. And then I'm going to distribute this as a negative 2. So I get negative 2 times 5x, which is negative 10x. And negative 2 times negative 1, which is positive 2. And now I look to see if I have like terms. And I do. I have 14x plus 21. And at this point, I can just add the like terms together. And I have negative 10x plus 2. So if I kind of keep those separate, 14x plus a negative 10x is positive 4x. 21 plus 2 is 23. positive. And there's my final simplified answer for that example. Here, I just have one polynomial with one term on the outside. It's got x squared. I am distributing the term. When I'm distributing this is different than when we were distributing an exponent from the outside. I'm distributing this as a whole term. So it's 2x squared times x to the third. And when you're multiplying these x's together, you're adding those exponents, and you get 2x to the fifth. 2x squared times 5x, that's 2 times 5, which is 10 and positive 10. So 10, x squared times x. There is a 1 up here, so 2 plus 1 is 3, so x to the third. And then over here, I have 2x squared times a negative 8. And 2 times negative 8 is negative 16. X squared has nothing to multiply by other than just so leave it by itself. So you get 16x squared. I look through here, there's no like terms to combine, so therefore I am done. Okay, looking at this last example, we have, just like the above example, we just have to distribute this y to the 1/4 to multiply times y to the 1/2. And we are going to distribute and multiply y to the 1/4 times 2y to the 3/4. So here, again, we just need to add these exponents. And 1/4 plus 1/2 is the same thing. I need a common denominator here of 2 goes into 4. So I can multiply this by 2 on top and bottom. And I get 1/4 plus 2 over 4, which is 3/4. So I'm going to get y to the 3/4. That looks like a 9. Let me write that over. Plus the 2, and then y to the 4th times y to the 3/4. When we add these together, 1/4 plus 3/4 is 4/4, which is 1. So we just end up with 2y. And there's our answer. Okay, now here we actually have two binomials being multiplied by each other, which means we have two terms here that are going to get distributed in to be multiplied by the 2x minus 7y. So there's a couple ways to do this. Some people use what's called the FOIL method, and some people say that that is a 4-letter word, and they don't like to use the FOIL method because they think it limits them for understanding what to do with this. So I like to say it's a distribution of terms. You have two terms in this first polynomial that need to be distributed to the two terms of the second polynomial. So you're going to take the 3x, you're going to multiply it by the 2x there. Let me grab the thinner marker here. And you're going to multiply 3x times the negative 7y. So 3x times 2x and 3x times the negative 7y. You are also multiplying 5y times 2x, also the 5y times the negative 7y. When I multiply 3x times 2x, 3 times 2 is 6, x times x is x squared. When I multiply 3x times negative 7y, I multiply 3 times negative 7, that is negative 21. X times y is just going to be written as xy. 5y times 2x. 5 times 2 is 10. Y times x, they're different. I'm going to just leave them as two separate variables. And I'm going to put them in the same order as I have them up here. I don't have to put y then x, even though it's listed y first and x second. I'm going to put them in the same order as the one above so that I can see that these are like terms. 5 times negative 7 is negative 35. Y times y is y squared. And now I have these two like terms here. And if I add those together, I get negative 11xy. So I've got three final terms here in my answer, and I'm going to put those and add them together. So 6x squared plus negative 11xy plus negative 35y squared. Now, obviously, anytime I'm adding a negative, I can convert that to be minus. And here is my final answer. Now, in the notes that I gave you, I show you a method called box method. So if you need this method and you need to write this down, press pause right now because I'm going to erase all this and then show you the box method. So let's go ahead and erase this. Let's move these out of here and there we go. Now the box method is taking your first polynomial and writing it. You could write it on the top, and then your second one, you're going to create a box based on the number of terms that you have. I've got two terms there, so I'm going to divide and make that two columns. And then I write 2x minus 7y. I've got two terms there, so I'm going to go split down the middle. I create four little boxes inside, or cells inside this box. And to complete these and fill in these cells, I multiply the term that is in the column times the term that is on the row. So 2x times 3x, I see that I'm going to get 6x squared. Over here, I have 2x times 5y, and that is going to give me 10xy. Right here, I get negative 7y, and positive 3x, which is negative 21. And again, I'm going to put xy. Usually you put the letters in alphabetical order. And then negative 7y times 5y is negative 35y squared. The interesting thing about using the box method is you will always have these diagonal values that are like terms. And then the corners are going to be individuals. Okay? And so if I look at those and I take negative 21xy and plus 10xy, that's negative 11xy. So I've got that as an individual term. I've got my 6x squared and my negative 35y squared. So I'm going to go ahead and write these from top left to bottom right, and the middle terms create that middle term. So 6x squared, and then again, like I said before, minus the 11xy because it was a negative, and then this is negative also, so minus 35y squared. Either method works completely fine. You are doing the same process. Some people see the other way better. Some people see the box method better, and they understand it better. And you can do this one the same way. You can do it either the distribution of terms or using the box method. So if I do distribution of terms, I do 2x times 3x squared, 2x times 6x, 2x times negative 5. And then this is a negative 8 there because of that minus. So that's negative 8 times 3x squared. Negative 8 times 6x. Negative 8 times negative 5. Go ahead and multiply these out. I'm going to get 6x times x squared is x cubed. 2x times 6x. 2 times 6 is 12. X times x is x squared. 2x times negative 5. All I have is to multiply is 2 times negative 5 to get negative 10x. Negative 8 times 3x squared. Negative 8 times 3 is negative 24. X squared stays the same. Negative 8 times 6x, I get negative 48, and then the x. And negative 8 times negative 5 is positive 40. I'm going to, as you can see, I've got a 6x cubed. Hold on, let me write that over. 6x cubed plus 12x, it's positive, so plus 12x squared. Minus, it's a negative, so minus 10x. And this is a minus or a negative 24x, so I'm going to put minus 24x squared underneath this other x squared. So minus 24x squared, because I'm going to line these up vertically again. This is a negative 48x, so I'm going to put minus 48x, and then this plus 40 over here. So I'm going to separate these as in columns, just like I did before when I had to add my polynomials, and I'm going to add these together. Anywhere I have a blank, I'm just going to put a 0. 6x cubed plus 0 is 6x cubed. 12x squared plus a negative 24x squared is negative 12x squared. Negative 10x plus negative 48 is negative 58x, and 40 plus 0 is 40. And there's my final answer. And again, you could do this as the box method where you set up, you could do, if you want, I always put the longer polynomial on the top. So I have the 3x squared plus the 6x minus the 5 when I'm creating my box. And you're going to have 3 columns. And then this was 2x minus 5, right? Nope, 2x minus 8. For your 2 rows. And again, you're going to fill in. So you're going to get your 6x cubed. 2x times 6x is 12x squared. 2x times negative 5 is negative 10x. Negative 8 times 3x squared is negative 24x squared. Negative 8 times 6x is negative 48x. And negative 8 times negative 5 is positive 40. And again, just like before, your diagonal values are going to be like terms, and you can add those together. And here you get your negative 12x squared. And here you're going to get your negative 58x. And you start here. And then there's your next term, your third term, and your fourth term. So you're going from top left down kind of through to your bottom right. And you get the same exact answer as you got before. And I did that more quickly because I didn't need to explain the same multiplication process. But if you look at all of these terms up here that I got, all of these terms right there, are the same 6 terms that you get in this box. All right, that's it. Sorry for the half-hour video.